Okay, well, some of you had some questions about the 7-4 homework and the 7-4 notes, so I thought I might show you guys how to solve number 9 and number 17. First thing you'll notice that's a little different between these two is number 9 has just one logarithm on one side of the equal sign, 17 has a log on both sides. So if you want to solve something like 9, then what you're going to have to do is you're going to have to be all you have to do is convert this into exponential form. So when you turn this into exponential form, what that does is that's going to cancel out your log on the left. So that's no longer there. And then you're going to end up getting x equals 25 to the power of 5 halves. So we all remember that 25 is just equal to a 5 squared. And so when this happens, then what you can do is you can cancel out your 2's. That 2 cancels with that 2. That's going to end up and leave us with x equals 5 to the 5th power. So 5 to the 5th power is a small tiny number, 3,125. So this is your solution for number 9. Now 17 is a little bit different just because, like I said before, you have a logarithm on the left and a logarithm on the right. Nice thing is this is actually easier than number 9 because what happens is your two logarithms just cancel out. You don't have to worry about converting something into exponential form. So what we're going to do here on 17 then is we're going to set what's behind the logarithms equal to each other. So we get 3x minus 10. And when we solve this equation, then what we're going to do is we're going to subtract 3x to both sides. And we're going to end up getting x squared minus 7x equals negative 10. So then next thing we want to do is we want to add 10 to both sides. So when we add 10, that's just going to give us our equation of x squared minus 7x plus 10. And remember, anytime you have an x squared, that means you're going to end up getting two solutions. So we need to factor this, and this will factor into x minus 5 times x minus 2, which means you're going to have two solutions. You're going to have x equals 5 and x equals 2. And most of you are going to stop right there and say, yeah, I'm done. But unfortunately you're not. What you need to do with these two numbers is you're going to need to check them and make sure that they are correct solutions. Now, how do you check them? Well, the only thing that is different about a logarithm than other equations is you just have to make sure that whatever is behind your logarithm is positive. It can't be negative, it can't be equal to 0. So both sides have to be greater than 0. So if we just plug our 5 back into both sides, then you're going to end up and find out whether both of these can be solutions. So if you plug a 5 back in, then what's going to happen is you're going to get a 5 squared minus 20, and that will give you a positive 5. So it's okay on the left. If you plug it in for the right side, you're going to get a 15 minus 10. And what happens is both of these work out. So 5 is a great solution for this problem. Now if you plug in a 2, you're going to get a 4 minus 8. And 4 minus 8 equals a negative 4. So obviously this will not work, which means you don't even have to check over here on the right. But we know that 2 will not work as a solution. So your only solution is going to end up being x equals 5. So make sure you plug your values in. You don't have to make a table, but if you just do it in your head, you have to check your solutions. So I hope this helps out a little bit, and I will see you guys next class.